Hello guys, welcome back to Intellect Insight. I hope you all are doing well. In today's video, we will see how exactly blockchain technology works. So, our title is Blockchain Explained very simply from black money to Bitcoin. Now, first thing first, before starting anything, what exactly you are going to get from this video, right? So the problem with centralized system and black money, this will be our first point. Second point will be why decentralization is the solution. Third, introduction to blockchain technology. Fourth, understanding blockchain with a real life example. Fifth, anatomy of blockchain block. Sixth, how blockchain ensures data security. This is the key nowadays, the security of our data. Seventh, proof of work and adding time-based security. Eighth, consensus mechanism, network agreement and trust. Ninth, real-world applications of blockchain. 10th, how to build or use a blockchain. Though we are not going to go in deep for this video, but in upcoming video, yes, definitely I am going to show you how to construct a blockchain and we can use it in our real life applications. 11th, smart contracts and solidity programming, using which we can develop one blockchain, right? We will discuss very briefly in this video. So stay tuned till the end of this video, right? So first thing first, what exactly the problem with centralized system? So very briefly, if I can tell you, it's there is no public access to the data which has been stored in database. And second, admin can change record anytime, anywhere as well, right? So nowadays, as we all know, there is black money everywhere in the world. Some of the transactions has been recorded and many of them not. But even if those transactions which has been recorded, there is no public access to those databases, right? So we don't have access at all, and it's not reliable because we don't have any public access. Second point, admin can change credentials anytime and anywhere as well, like we don't have access at all. That is why we need some solution which is more decentralized, and that is blockchain all about. Now second point is based on the first one. Because of there was some sort of issues with centralized system, now we need a solution which is blockchain, right? So here our second point, why decentralization is the solution, why exactly it works. So we need a solution which is a decentralized in nature. So how it proves? So it has shared control, not in one hand. Not a single person can change credentials from anywhere. No, we cannot do that in decentralized system, right? So it has shared control. So it's not in one hand. And second, trust through transparency. There is transparency in all transactions. So authority isn't with one person, it's shared by all. And second, data is nearly impossible to change or tamper with. Now let's move to third point, introduction to blockchain technology. So we can trust such a system because it's a secure and transparent in nature. This kind of database or system is called a blockchain. So it's a secure, tampered proof, so no one can alter the data and stuff, and it's a digital in nature as well. So nowadays, as we all know, each and every task, each and every transaction has been moved online, right? First used in Bitcoin 2009 by Satoshi Nakamoto, right? Who is the founder of this specific technology, who is an anonymous developer, used blockchain technology to create a Bitcoin, which we heard nowadays here and there, right? So Satoshi Nakamoto was an anonymous developer. First research started in 1990 and implemented in 2009. Okay, so this is all about introduction of blockchain technology. Fourth, understanding blockchain with a real life example. How exactly we use blockchain technology in real life applications. So let's example, you have one shop nowadays, and also in past few years as well, people used to keep logs in their logbook, like what sort of item I need for shop. So they used to write on a book, right, each and every transactions. 5 rupees or $5 milk has been imported from this particular shop to my shop. This much is the price, and where it go, like who purchased, how many quantity has been purchased, everything in one logbook. So blockchain technology works exactly like that. For example, in a shop keeps record of stock flow, right, what stock has been flowing in and what is going out. First, where stock come from. Second, how much they paid and from whom. Third, where the stock goes. All written in one book called a ledger or record book. Single record, single block in blockchain means in blockchain it's a chain of many blocks. Each individual block has, you can consider like a single record book which we use in a shop, right? For example, if you have 10 shops, so each block represent every single shop, and each shop has a record book, so each block represents one record book. You can consider like that, so you can understand easily, right? Blockchain is equal to chain of blocks, and each block holds records or information. Each block stores related data for Bitcoin, like transaction details in Bitcoin case. Then blockchain can be used for different use cases with relevant data in each block, right? So as you can see here, as we have discussed about record stocks in and out, one record is equal to one block, and blockchain is equal to chain of records, like means chain of blocks. Fifth, anatomy of a blockchain block. How exactly blockchain block constructed? So if you want to understand that, let me show one diagram for you, right? So this one block chain, and this another block, right? Each block represents record book in simpler terms. Each block has one record book in which there is a data. But how data has been constructed? So each block has, let's say this is one block. First thing, data. Second thing, hash, a unique fingerprint like Aadhaar number. It's generated based on the block's data. So second is hash. And it's a unique value for each block. Third one is previous block's hash, right? Links the current block to the previous one, creating a chain. So previous block hash. So each block has these three value. First is data, what that block made up of. Second is hash, and third is previous block hash. So it links one block with the previous one, right? That is how blockchain has been constructed. Now, there is some sort of security issue as well, which we are going to see in a while, right? The first block has no previous hash. It's called the genesis block. Let me show you. Let's say this is one block, then there is another block, there is another block. So for example, it has hash value of a. Previous hash it has 0 0 0 because it is the first block of the chain. Now second block, so this block has a previous block's hash. So here previous block hash will be a a a, and this block hash will be b b b b. This is the unique value for this block. Again here previous hash will be b b b b, and hash value will be for this block c c c c, right? So now what is genesis block? Genesis block means the first block which has no linkage to the previous block. Here you can see there is 0 0 0 0. That means it's the first block of a blockchain. So you can call this block genesis block. Genesis block. Okay, this is what we are discussing about. Yeah, here we discussed about data hash and previous blocks hash, right? So as I've discussed, it's a genesis block if it's the first block has no previous hash value. Then from the second block onwards, each one stores the previous block's hash. As we have discussed here, you can see the second block has a previous block hash, right? A. Here same B. Then that's how blockchain becomes tamper-proof. Each block links securely with the next. Information stays unique and traceable. You can easily traceable from where this specific information is coming because of this previous block hash and hash value, because it's a unique in nature and it is linking one block with another one. Any changes break the whole chain. For example, let's say if someone wants to change the information in this second block, so let's say if you make changes here, instead of BBBB, if you say BDBB, right, then in the next block means here you can easily see that there is an address of BBBB. So now it will look for this address and someone changed address here. So all the blocks from here onwards, further blocks will be invalid. It's wrong. So that means you can easily detect where is the issue and what's the problem. That is how it's more secure. Any changes breaks the whole chain, because if you make change here, all the blocks from here onwards will be like faulty, you can say, right? So tracking becomes easier and trustworthy. That's why blockchain is considered highly secure. Now let's move to the sixth point. How blockchain ensures data security, right? So blockchain uses multiple layers of security. If someone tries to change data in one block, that block's hash changes instantly, which breaks the link to the next block. The previous hash in the next block becomes invalid. That's what I've discussed with you guys, right? And chain gets corrupted and tampering is exposed. Where is the tampered happen, right? You can easily detect that. That's why data in blockchain is hard to alter. Any small change breaks the entire chain, right? Let's move to the seventh point. Proof of work, adding time-based security. So in Bitcoin, changing the hash of one block takes about 10 minutes. It's very time consuming, even if you want to change a hash of even single block. So everyone can detect easily. And if you decide to change 1 crore blocks, each block takes 10 minutes, then it will be approximately 200 years to change data of each and every block in the blockchain, right? And proof of work means you must prove that you have spent real time and energy like 10 minutes. So it's you have to prove actually you have spent 10 minutes on changing that specific hash value to generate a valid hash. And another layer of security which we are going to discuss in next point, probably consensus mechanism, which is also another layer in blockchain to ensure the security. Right, here it is. The consensus mechanism, network agreement, and trust. So, what exactly it is? Everyone in the network has a copy of a blockchain. So, if you try to change one block, you can't do it alone. Before making a change, you must share it with the entire network. Then the network uses a voting system to decide if your change is valid or temporary, because you need to get assurance from each and everyone who is in the same network. So let's say if you want to make a change, you can't do it alone, right? You need approval from the entire network. It's kind of a voting system. If the majority rejects your change, it's not accepted into the blockchain. So you need to have a majority rules, and trust is built that way. So it's another layer of security via consensus rule. For example, if you want to add new data or a new block to the blockchain after spending 20 minutes proof of work, which we have discussed earlier, you must first share it with the network. The network members then verify the data. Only when the majority agrees, the new block is added to the chain. This process ensures trust, transparency, and strong security in every update. So it makes sure that no one is changing without any kind of approval from the network. Right. To harm or tamper with a blockchain, first you must spend a huge time change the hash of each block, and then you must control the majority of the network to gain enough votes using consensus rule. So there are two layers of security. First, which we have discussed earlier, proof of work, and second, consensus rule. First one is based on time, like you need to spend lots of amount of time to change hash of each block, so it's practically impossible. And then it's a voting mechanism, so you alone cannot make a single change. You need approval from the network, and it should be in a majority. Then only you will be able to add new data or make a change, right? Let's move to the interesting point, which is real world applications of blockchain. After all, whatever we are learning, we want to implement that, right? Otherwise there is no meaning of that. So blockchain technology can be used for many purposes, but currently the most popular use case is cryptocurrency like Bitcoin. It's in a hype nowadays, isn't it? Like, because everyone is talking about crypto, Ethereum, meme coin, and what's not, right? But first we need to understand what's the actual applications of blockchain, right? For example, if you want to send money from Canada or USA to India, traditional method which goes via bank. So it's like money, after you send money, it goes through a bank. Bank charges high fees, but with crypto there is no middleman like a bank is needed, right? So you can directly send Bitcoin from person to person. You don't need to pay any sort of fees in between. You just transfer Bitcoin to Bitcoin, similar to gold to gold. Same value you will get to the receiver end as well. So it's the same way. Fees are much lower and transactions are faster. Just like gold, as I said, right, is sent as an asset. Bitcoin is sent as a digital asset, right? It's a simple. Then also, uh, as we have discussed crypto already, then there is a real estate, tamper-proof property records. For example, buying and selling records are stored on a blockchain. Let's say if you're buying a house or selling a house, those records are stored on the blockchain. This helps in tracking property history and prevent frauds. Nowadays, there are lots of frauds happening. To avoid those, we can use blockchain technology. This is a new use case which you probably don't know. Second one is healthcare. Patient records are stored securely in the blockchain and ensures data privacy, access control, and accurate history tracking. Like, after you store the data of patients, privacy has been maintained. You can access this because you have access, and no one can change their data because it has been stored in a blockchain, and you can accurately track those data from the past as well, right? It's a healthcare application. And then startup and projects. Blockchain is used to track funding, milestones, and ownership as well. Like who is the actual owner of the specific startup or an organization. You can store those kind of data in a blockchain, and it brings transparency and trust to investor and users as well. Because nowadays there are lots of agreements and paperwork happening, right? And anytime anyone can just change their mind and they are like, I cannot follow this document and stuff. But if you just write digitally and store it in a blockchain, it could be the great application, and it will be secure too, which might be helpful in our day-to-day life applications as well, right? Now let's move to the another point, which is how to build or use a blockchain. I know you guys are very excited about this point, right? How we are going to build blockchain, which I'm going to show you in next video as well, probably after few videos. So you can either build a blockchain from scratch or use an existing one like Ethereum, Bitcoin with code as well. There are two options. Let's say if you decide to build one with a code, then there is a language called Solidity, which is there in the next, right, 11 number point, which is smart contract and Solidity programming. So code based digital contracts are there. Inside a blockchain there is a smart contract. It's like a digital contract written in code. It defines how data is sent and received. Once added to the blockchain, transactions follow the code automatically. For example, there is some sort of contract in the block, right? As soon as data has been sent, or if you received some sort of data, the code works automatically, which has been there inside that specific contract, right? So once added to the blockchain, transactions follow the code automatically. Ethereum is a popular blockchain platform. It uses a coding language called Solidity. If you know basic programming, Solidity is very easy to learn. You can then implement blockchain logic into your own applications as well, right? So this very simple understanding of blockchain, how it works, how it maintains the security, what's the difference between centralized system and decentralized system. Thank you guys for watching me till the end. I really hope that you found some sort of value from this video. If you got some value, then please do let me know in the comment section below. See you in the next video. Till then, keep learning, keep hustling.